arithmetic. Now, in general, because the computer uses 2's complement, we will use 2's complement. In a question, they will tell you what the numbers are. Okay. So let's start with just simple addition. Now, we can't use a calculator, but the wonderful thing about this is the numbers are so easy, we know what the answer is. So if you get completely stuck in the exam, you always get marks for working out. You could at least say, oh, the answer's 3, write down 3 in binary. Okay, you might get a mark. Ideally, they want to know that you understand the process. Okay, so let's have a go. First off, let's just add 4 and 3 together. Which sounds ridiculous, but right, let's use 5-bit values because that's relevant. So let's write down 4 as a 5-bit number. So that's 4. Yeah, everyone happy with that? And 3. Obviously, neatness is important. Right, what I'm not going to do is put the plus on that side, which everyone seems to do in maths. Now let's put it over there, out of the way. Do a nice neat line and another nice neat line. I think in general in the exam questions they tend to give you things like that and say add them together. Alright, but if you have, it might be a multi-part question where you've worked through and you've done some conversions to binary and then they say, ooh, add them together. And you think, yeah, alright, whatever. And so you do, so you add them together. So you might have to do things, but the key thing is make sure they're lined up. Because it's identical to decimal addition. If the columns aren't in line, you're going to get all over the shop straight away. And it's the same process. You just take pairs that are together and add them up. So, 0 and 1 is 1. Yeah, enough with that to put 1. 0 and 1 is 1. 1 and 0, ooh, different, is 1. And then 0 and 0 and 0 and 0. What can you tell me about that number?
7.
It is 7, we can see that. But what else can you tell me about that number? Assuming it's a signed number. Yeah, it's positive, it's signed, but it's not. Okay, so the answer is 7, but we knew the answer was 7. Yeah, everyone happy with that one? That is the process, but let's try and tricky a number. He says picking his nose on camera. Right, let's add. We'll keep with 3 because I like 3. It's a nice number. Let's add 3 and what number is that? 6. Okay. What's the answer? 9. Okay. What's 9 in binary?
0, 1, 0, 0, 1.
Yeah, it's quite a nice number. 9. I quite like that because you get like the ones on the end. And you can do funny shapes with it, put ears on it and stuff. Like that. Right, okay, so same process. 0 and 1 is 1. Right, okay, woo! Scary. 1 and 1 is?
0.
Why is it 0? Right, if I add 1 and 1 together, what actual number do I get? 2. But you can't write 2 in binary. What does 2 look like in binary?
1, 0.
Yeah, 1, 0. So we write 0, and because we can't put 2 things in one column, we carry 1 over. So we say 0, carry 1. Everyone happy with that?
Mm-hmm.
Yeah? Okay, carry on to this next column. So we've got 1, 0, and then we've got this carry. So that's 2 again. So that's 0, carry 1. Then we get 0, 0 and 1. And 0, 0. Oh, look, magically it's 9. Now, I've written the carries here because that's what I've always done it. I've always written. But does anybody put the carries at the bottom? Whatever method works for you, stick to it. I specifically don't like that. I think it's horrible. But that's my opinion. You can completely disagree with me. I don't care. Okay, I'll still do it my way. I tend to, if I start writing them at the bottom, I end up all over the shop with them. That's what I find. Because it's so far away from all the other digits. And you're like going, oh, I've gone a bit diagonal there. Which one was that with? Okay. Anyone got any problems so far? Right, okay, let's try another number. Let's add What should we have? Those two numbers. What are those two numbers? 7. So we've got 7 plus 7. What's the answer? 14. Everyone happy with that? Yeah. What does 14 look like in binary? In these 5 bits?
0.
It's going to be a 0.
1, 1, 1, 0.
Okay. What's that in hexadecimal?
E.
Trick question.
E.
It's not E.
Oh, that's a lot.
How many bits have we got?
Oh, 5.
5. So what would it be?
Is
0 E. Don't let them trick you. Okay, remember 4 bits. And then we got a load of zeros with a digit. Got to be careful about that. Right, so hopefully we're going to get that as our answer. Let's see if we do. So we got 1 and 1. Now we know that's 0 carry 2, 0 carry 1 because it's 2. Ooh, another complication. We got 1, 1 and 1, which is 3. So that, because 3 is that in binary, it is 1 carry 1. Ooh, got another one. 1 carry 1. And then it's 1. And then it's 0. Ooh, look. Yeah, it's 14. That's it. Don't get any more complicated than that. Okay. Anyone got any questions? Right, so you're all experts and you can all do binary addition. Alright, let's have a go at this one. Right, let's add. I'll stick at 5 bits. Okay, what are those two numbers?
15 and
Yeah, that's 15 and 4, so it should be 19, yeah? Okay, so let's do it again. So 1 and 0 is 1, 1 and 0 is 1, 1 and 1 is 0 carry 1, 1 0 and 1 is 0 carry 1, 0 0 is 1. Okay, that looks like 19, 16 and 3. But if these were signed numbers, what have we actually got as a result?
-3.
Yeah, we got a negative number. It's not -3. It was if it's sign of magnitude, it would be -3. If it was 2's complement, it wouldn't be -3, would it? So let's just do a flipping add just to see what the number is. So flip, 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 flip. Last one, leave it at that. It's actually 13, minus 13. Right, well last time I added up two numbers, 15 and 4, I didn't get minus 13. What's happened? What's happened with that? If we were to just say that was an unsigned number, that would be the right answer, wouldn't it? Because we just treat everything as positive. But if we're talking about signed numbers, what do you think has actually happened?
You can't get 19 with the amount of bits you got.
Excellent. We have got a number that is too big. What's the biggest we can have?
15. Total of 15.
Let's just check. I think you're probably right there. So if we do that, remember it is one less than that last column, isn't it? So 15, excellent. 15 is the biggest number we can hold. There is a term for this. Anyone know what it's called? It's the same thing that happens if you forget to turn your bath off. Overflow. Okay, we've basically ended up with a number that is too large to hold in the number of bits we've got. If we were using 8 bits, we'd have been alright. But we weren't, we were using 5 bits.
Will we get the mark in the exam when they say overflow?
If they ask you, if they say these are two signed numbers, and you add them up and you get that, you'll get a mark for getting that answer, but you will get, what they tend to do is they won't, I would always say, oh look, overflow, I could represent it if I had an extra bit. They'll ask what was unusual about the answer, or something like that. And if you don't know anything about this, you go, nothing, I got 19, it's alright. Alright, but they're testing, yeah, so they will ask about that. So that is an issue, but you can, we're not going to go into the logic of this, but you can detect when overflows occurred. And when we come on to the CPU, we'll talk about there's some special locations in the CPU that record what happened after mathematical operations, and overflow is one of the things that is tracked. Okay. So it is an issue, and it is something that has to be handled. You never worry about this generally when we're programming with high-level languages. Okay, so we don't have to generally worry about that. But that is overflow. You can only get overflow when you do a maths operation. If someone says, write down 19 as a 5-bit 2's complement number, that's not overflow. Overflow happens when we do some operation. Okay, very important that. Right, so everyone all right with that? Right, I'll stop the video there and I'll give you a few of these just to do. I'm not going to labour, I'll just give you 2 to do, and then we'll have a look at subtraction, which is horrible. Okay, so I'll stop that one.